The big caution that I want to make on absolute values is this sort of thing, where when you have an absolute value, don't ever simplify or try and simplify by making all your negatives positive, because that just isn't the way it works. These two in general are not equal. You can see that if x equals 2, if we first take 2 minus 6 and then take the absolute value, we get 4. But if we do this operation here, where we take the absolute value of 6 and then add it into the absolute value of x, we're going to get 8. So it's clearly two different numbers. So always treat your absolute values as a group. If you're eliminating the absolute value sign by setting up two different equations, you can keep them in parentheses if you want to just keep it as a unit. But most certainly don't try and do this term-wise, where you're inside the absolute values and you're changing the negatives to positives, because you'll get in trouble every time doing that. Okay, so if we have, did we talk about what happens when you have two absolute values in an equation? Okay, so I'll start back here. So let's say we have an equation that has two absolute value expressions in it. Okay, so if we have something like the absolute value of A equals the absolute value of B. Now, if we were to do this exactly the way that we did this one, where we have one absolute value, what would happen is that we would end up with four equations, where A equals B, A equals negative B, negative A equals B, or negative A equals negative B. And you find out that the inner two, the A equals negative B and the negative A equals B, is the same thing, and that the outer two, A equals B or negative A equals negative B, are the same things. So in fact, all we have to do is two different cases. So we basically treat these two expressions A and B, put them in parentheses. One of them you keep it the same, the other one you change the sign of one side. So for an example here, if I have two absolute values expressions and they're in an equation, what you do is you take just remove the absolute value signs from both sides, and so that's the positive version of both. And then where the signs differ, all you have to do is put a parenthesis around this expression that's inside the absolute values and stick a negative sign in front of it. So this is properly set up the way it is, and now you can solve these just as you would any normal linear equation. So I would strongly recommend you use parentheses here and not try and write this thing by negating all the terms, just so you're only doing one operation at a time. Oftentimes you'll make mistakes just because you overlook something, or maybe you don't treat a double negative right or something like that. It's not necessarily because you don't understand it, it's just because you have a tendency to not do some things as you do a whole bunch of these kinds of operations. So write down your equations with parentheses, use the negative in front, then you have the ability to do a little bit more careful job. So we'll look at solving the left one first and then the right one. And so on the one on the left here, I'm just basically adding 6 to both sides, and then I'm subtracting x from both sides and then dividing by 2, and I come up with x equals 4. On this other one here, I have to distribute the negative, and this negative and that negative make a positive here. And if you're working quickly, even if you understand this stuff really well and you make a mistake, probably 80% of the time, this is where you're going to make your mistake. Okay, so keep that in mind when you're doing some work or you're taking a test or something like that. If you want to look over and you're looking for things, where are my likely mistakes, go right there. Take a look at the second or third terms that have negative signs in front of them and see, did you treat those right? Okay, and you can pick up a couple or 3 points every time by doing this if you make that kind of mistake. I make the mistake quite frequently, and I've been doing algebra for, I don't know, decades, right? It's still a mistake that you make, and it's not a question of not knowing it, you just make mistakes inherently, right? Okay, so then we'll finish that one up, and we find that x equals 1. And so we can stick them in the equations. And I know this is playing out faster than you can write, but let me go back here. Where I'm going to stick the 4 in on this side, where I have 4 plus 2, and then 3 times 4 minus 6, and then simplify those, and I find the absolute value of 6 equals the absolute value of 6, and that's always true. One caution, I think I mentioned it on Wednesday, don't put this x in one of the x's and this x in the other x. The x has to be the same x on both sides, okay, so don't mix them up. So if we try on the other equation where we stick the x in where x is 1, and then we'll find that this absolute value of 3 equals the absolute value of negative 3, which 3 equals 3, and so we're good there. Okay, so I think I said earlier when you're doing linear equations you don't always have to check it. I've shown you that I've checked it sometimes and not checked it other times. One of the things about absolute values, though, is that you may end up with what's called an extraneous answer. That means you've done everything algebraically correctly, and then you check your answer and it doesn't work. Okay, and that will happen. So you must check your answer to see if these things work. Where it generally fails is that the absolute value doesn't really take into account, you know, what happens on the other side of the equation, or the other side of the equation actually is some negative number or something like that, where in reality you have an impossible situation, but by handling it according to these steps you actually get a solution. So it's important to check it. Occasionally you find an answer that doesn't work and you discard that answer.
Is that what you're talking about with the 3 equals negative 3?
No, this works, okay? So absolute value of 3 and the absolute value of negative 3, they both is 3 equals 3, so this is true. Both of these work. All right, everybody up with this? Okay, so why don't you try a couple of these. Try this one. It's very similar to the one that I had before, but I'll give you a little practice on this. What'd you get, Macaulay?
0. X equals 0.
X equals 0. Okay, and then another solution too?
I just got 1. I just solved for 1.
Okay, you should always attempt 2 solutions on this because it's only half the problem if you just remove the absolute value signs. Anybody get another answer besides 0? Yes.
X equals 2.
X equals 2. Okay, so if we can probably try these in our head if we just look at it. If it's x equals 0, then we have 0 plus 1 equals 1 minus 0, so that's 1 equals 1, that one works. And then 2, we have 2 times 2 is 4 plus 1 is 5 on one side, and then we have 1 minus 6, which is negative 5, and the absolute value of that is, of course, 5. So we're good on both sides. Okay, so this is the way I set it up. Important to set up the second case. It's not good enough to do just one of the cases. And then just use what you know in solving linear equations to get to both solutions. And then we check. Okay, everybody get that one all right? Okay, so on this one, again, be sure to use the parentheses around. Don't try and, I suppose on this one simple enough where you could have said negative 1 plus 3x, but I think it's a lot more reliable if you start out with just putting the negative sign in front of the parentheses. Okay, here's another one. Anybody get anything? Riley, did you get it?
Yeah, for the first one, I got no solution, and then for the second one, I got x equals -4, so it's extremes.
Does negative 4 work then? Okay, you haven't checked it. All right, so let me go through it. You are right on the first one. You can see it from here that you have 2x plus 7 equals 2x plus 9, and so if you subtract 2x from both sides, you get 7 equals 9. So that one doesn't work. But that doesn't necessarily mean that this one won't work. So if we set this one up this way, and we solve both of them, we find that x equals -4, just what you said, and then we will test that. And so we have -1, or the absolute value of -1 equals the absolute value of 1, and so 1 equals 1. So here's a case where we only have one solution, where the equation that we set up on the left has no solution, the equation that you set up on the right has a solution. So there's one solution to this. Okay. So let's look at absolute values and inequalities. And I want to talk about this again in the context of having absolute values as the distance between two numbers. And so when we set up an absolute value equation, we have two solutions. If x minus 6 equals 3, x equals 9, or x equals 3. And so if we put that on the number line and graph it, so you see what's going on here, where this 6 that's in here, we're asking what's the distance from x to 6 is 3. So what is 3 away from 6? Well, if we go to the right, it's 9, and if we go to the left, it's 3. And so that's kind of the physical meaning behind this kind of an equation, that you have the absolute value of x minus 6 equals 3. So you're asking, what number's distance from 6 is 3? It's kind of a plain English way to say that. Now, we want to get into inequalities, all right? So let's look at the same kind of thing with an inequality. So if I put this into the context of what does this mean, I can say the distance from x to 6 is more than 3. Yes. Yeah. I know my app scrolls way faster than you can write, right? All right, so can I move on then? All right, so let's look at a modification of that equation. Say the absolute value of x minus 6 is greater than 3. So then kind of the physical meaning of this thing is that the distance from x to 6 is more than 3. All right, so think about that, the way that solution is going to play out. All right, so if we draw this on a number line, and from 6, we want everything more than 3. So we end up with these two areas that are not overlapping, right? So let's say, if that's a location, you want everything to the left and everything to the right of it to be more than 3. So you definitely have two different intervals that need to satisfy that equation. So if we were to solve this, what I'm going to do here is take a step back and remember when we have the absolute value sign. The absolute value sign either does nothing if x minus 6 is positive, so we just get this equation. But if x minus 6 is negative, it changes the sign of it. So it's the negative of this negative number. And so we get this thing here. Now when I rewrite that, okay, I can multiply both sides by -1, but look what happens here. I change my inequality from greater than to less than. So it's perfectly fine if you want to write this as your first line, where you keep that x minus 6 just the way it is inside the absolute value. You make the right side negative like we did with the inequality, or with the equality, the equation. But since we have an inequality, we have to change that sign from greater than to less than. Yes?
So I'm a little confused. Are you saying that we can distribute that negative and not change the sign, or change the sign? Like we have two options?
Yes, you do have an option to solve this directly. Okay? So long as you obey all the rules. I'll do it on the board when I finish this, and you'll see it, you end up with the same thing. And then I'll show you a case where it's absolutely better to do it this way. Okay? All right, so we'll just solve these, and we get x is less than 3, and we check it. And here, when I'm checking it, it's hard to check an inequality. What I'm going to do is, my solution says x is greater than 9. All right, so I'm going to choose x equals 10 because 10 is greater than 9. So this should be true if 10 works. Okay, so if I put 10 minus 6, I get 4. 4 is greater than 3, so this is true. Now on this one, I'm saying x is less than 3, so I'm going to choose a number that's less than 3, which is 2. I'll stick the 2 in here, and I end up with a statement that is true, because the absolute value of -4 is 4, and I get something that's true. Okay, so back to the question of what can we do here. Can we use both of them? And we certainly can. We can use either of them. So let's say we just kept it this way. Everything is right here. I didn't need to change in fact, I shouldn't change the direction of the inequality because I'm operating on this side, and what the absolute value does with this expression is it changes the sign when this is negative. Okay, so let me distribute that. And then I'm going to subtract 6 from both sides. And now I'm going to multiply both sides by -1, and I get x is less than 3, which is exactly what I got the time before. And so I'm still in a position where I'm changing the direction of the absolute value, or the inequality. Yes.
So it's just the longer way of changing the sign because you're dividing by a negative eventually.
Yeah. So I essentially do this step first off when I change this and make this negative. Okay? Now, if you're clever about how this goes, let's say you have something like this, where it's 6 minus x is greater than 3. Now here's a case where, the first side you do like this, and then the second side, since you know you have this negative x, if you do it like this, then when you distribute this, you get -6 plus x is greater than 3, and so then, lo and behold, you get, by adding 6, you get 9. So you don't ever change the inequality sign here. So you can pick and choose. Most people settle into a habit of always doing it this second way, where you, I guess that's not what I wanted to do here. Where you automatically change the direction of the inequality and make that sign negative. And if there's an expression here, make sure you put it in parentheses to make the whole expression negative. But it's really up to you. And what I would like you to do is kind of cultivate really an understanding of what's going on here, so you can be kind of selective in efficiently solving these things. Okay, so just to repeat the point here, when it's greater than, we're going to end up with two regions where this is true, right? Either completely off to the left and completely off to the right. So it is an or, because you can't be, like if I say, let's say this classroom here is 30 feet wide. I want everything 15 feet away from me. Well, it's either going to be on that side of the wall or it's going to be on that side of the wall, but never both at the same time. Now, if I have the other inequality where it's less than, then I want it within, and so it has to meet both of the criteria, and you get an and. Okay, so when we have a less than, it's the distance from x to 6 is less than 3. So it's within 3 is another way to look at that. So this case always turns out to be where it has to meet both criteria. Okay, so now it's in this one interval. And that's like me saying if I want everything to be within 15 feet of me, it not only has to be inside or within this wall, it also has to be within this wall as well. And so the less than always suggests that you have a situation where both parts of the equation has to be true. So we make that an and. And here again, I'm going right to flipping the direction of the inequality and making the 3 negative, and then solving from here. So this and is going to be crucially important because both of these have to be true, not just one of them. And so the arithmetic here is very, very similar. We get down to x is less than 9 and x is greater than 3, and you can condense that into one inequality statement like this, where you say 3 is less than x is less than 9. So just to kind of illustrate what I'm talking about here, x has to be greater than 3. Now if x was 10, it's greater than 3, but it doesn't work in this equation because x also has to be less than 9. And if I choose x to be 10, it's not a solution. Yes?
Sorry. How do you figure out if it's and or?
It's the less than is within, okay? And the greater than is outside of, and so the greater than is or, the less than is within. And so you can just, make that in your notes if you want. So if you have the absolute value is less than some expression, all right, so I'll just say it like this. This is within, so that's and if it's like this, that is going to be or, when it's greater than. And the same is true when we have the greater than or equals and the less than or equals. Here I'm speaking for both cases. Okay, so we check this. So 5 is between 3 and 9, and so if we plug 5 into the equation, we get 5 minus 6 is negative 1. The absolute value of negative 1 is 1, so 1 is less than 3, and that's a good way to check. Now, if you forget, let's say you're not sure, is this and or? Okay, one of the things that you can do is visualize the number line and say, okay, let me pick a region, let me pick a number that both of them are true, or let me pick a region where only one of them is true. So we can try like 3 different numbers here. You can try 1, 5, and 10 and see which ones are true and which ones are not, because you've already established that 3 and 9 are kind of the boundaries there. So if you really do just forget, and you're pretty sure that the less than is in between the two, try a number in between. And oftentimes, it's not in this case, but oftentimes 0 is in there, and 0 is a very easy number to compute with. So if you notice that 0 is between the two bounds of your inequality, try it out. If it's true, you're right. If it's not, then somewhere you made a mistake. Yes?
Okay, and then, so if you put it on a number line and your two x's that you solved are 9 and 3, and you go 3 to 9 on the number line, and then halfway point, the 6, should that be in your original problem? Is that
It doesn't have to be the halfway point. It can be any number in between the two.
Oh,
I chose 5, okay? 6 is perfectly good. If you put a 6 in there, then you get 6 minus 6 is 0, and 0 is less than 3, so it would be true. So all the points are true. So you don't have to choose the midpoint. And that's my point about if 0 is in there, use 0, because 0 will be your easiest calculation. Okay? All right, so why don't you try one? 7x minus 3 is greater than or equal to 11. Hey, Mark, did you finish? Did you get it?
Yeah, I got x is greater than or equal to 2, and x is less than or equal to negative 8/7.
Okay, so is this an and or an or?
Or
It's an or, and that's because it's
it's
greater than, right? So you want that distance between 7x and 3 to be more than 11. Okay, so I think this is probably what you did here. 2 and negative 8/7. Okay, and then we check it. Now when you have the equality, you'll notice that I come out with the equals if I make the direct substitution of, and you would expect that the border number is where it's equal. I could have also chosen another number. If x is greater than or equal to 2, if I chose 3, for instance, I'd still get something that was correct. So instead of 7 times 2, it would be 7 times 3 minus 3, which would be 21 minus 3 is 18. Absolute value of 18 is 18. So we have 18 is greater than or equal to 11. So you know, you can test it that way, especially when you have the equality. Sometimes it will tell you that you have the boundary right, but it doesn't tell you if you have the region right. So choose something that is perhaps not the exact number, but something that certainly is within the interval that we're looking at. Okay, so here's a different one. Now, one of the things that I didn't really talk about at all is that when you have operations that are on the absolute value, like this one's divided by 4, first isolate the absolute value. So if I had even something that was added to that, I would try and bring everything over to the other side of the equation and just leave the absolute value on one side. And that's how you do that. Nathan, did you have a question?
Yeah, on this one, like for the 7x minus 3, like greater than negative 11, I don't know why you put a negative on that 11.
Well, you should put a negative over here, right? Because this is the case where if this is positive, then the equation looks like this because the absolute value doesn't change anything. But if 7x minus 3 is negative, you have to turn this around because you're multiplying it by negative 1. And so in this case, you turn it around and make the 11 negative. And in fact, if you follow down the way you're checking, if you put in negative 8/7 and you're looking here, you see you get to the point where that expression 7x minus 3 is negative, and it does turn it around to a positive. Okay, Jaslyn, did you get it? Your arms are folded defiantly, I see.
I got y is less than 136 and y is greater than negative 1.
Okay, and you check those? Okay, good. So what's the first thing you did here?
Well, I multiplied 4 to both sides.
Okay, so you get something like this then.
Yeah.
And then you set up your two equations. Like that. Good. Okay, so you get 136 and negative 104. And you can write it together. It's not wrong if you don't write it like that. Certainly it's your choice. And if I plug those two in, we get it. So the computation on these were fairly straightforward. Okay. So that does it for absolute values and inequalities. The trap here occasionally is that you don't do everything on one side. Like if you have a little bit more complicated expression where you have something like this. Okay. Remember to isolate the absolute value first. So the first thing you would do is you would subtract 4 from both sides. And then you would divide by 3. And now you have something that's familiar that you can make your two expressions with. So always isolate it. The other thing is, when you have this, this business here, okay, whether it's an inequality or an equality, if this side is negative, if you have something like this with an equality, you know, just by looking at it, there's no solution because an absolute value is always 0 or positive, and that's negative. So if you come across this, don't feel like you have to work it any farther. Just point out the fact that this is always true, okay? It's always true, therefore this has no solution. All right? And actually, if you just stop and write no solution, I'll see that you caught it. So you don't really even have to explain it, although, you know, be aware that that's why it is the way it is. We're going to move into Chapter 3. And Chapter 3 has to do with graphs. And so we're going to start to deal with more than one variable in our equations. And we're going to talk about the equations of lines that have two variables in them. So as kind of the beginning of that, let's look at the rectangular coordinate system. Okay, when you draw a graph, the thing I'd like you to always do is to label your axes so they all have the 1, 2, 3, you know, where you just don't put the tick marks or you just don't draw an axis on a graph paper and leave it unlabeled. And then if we're dealing with x and y, it's perhaps not so important to label the axes, but we generally use these in this fashion where you have your x-axis, so all your x values are measured along this line, the y values are measured along this line. But I would, just as a matter of kind of good practice, is to label these x, and then label this one y. Okay, so you'll have a fully labeled graph that way. And so, you know, when you're asked on a question or on a test or something like that to fully label your graph, this is what I'm talking about, is labeling it to include these things. Now, where the two axes intersect, we call that the origin. Okay, so that's the coordinate point 0, 0. Now, we have what's called an ordered pair, and the ordered pair, the first number is the x-coordinate, the second number is the y-coordinate. And so the way that works is, oops, that's not what I wanted yet. the way that works is we have x equals 2, so anywhere along here, x equals 2. So it doesn't matter where it is vertically, horizontally x equals 2. And when y equals 1, it's along here, anywhere horizontally. And of course, where the two intersect, we have x equals 2, y equals 1. Now, just a matter of terminology too, we call the different quadrants on this graph, quadrant 1, 2, 3, and 4, and we start with where they're both positive, and then we go around counterclockwise. All right, so when we're talking about quadrant 2, we're always talking about this upper left-hand quadrant. The reason we do this is because, the way we number them this way, is because it makes sense, you know, you're dealing with positive numbers to start there, and then you go around 2, 3, and 4, because when we're dealing with trigonometry, generally the angles will be increasing that way, and so you go from quadrant 1, 2, 3, and 4. Now, we're not going to deal with trigonometry in this course, but ultimately this will be really important to you when you get to Math 14 and you're dealing with angles in the coordinate system. Okay, so we have our axes. And so the first one, I'm going to look up, you know, y equals 3, x equals 2, because the 2 comes first. And then notice that they are intersecting, so our point is there. Same thing with -3 and 4. We're going to look at -3 and where 4 is, and where they intersect, that's our point. X equals 0 and y equals 2 ends up on the y-axis, and then x equals 4, y equals 0 is right there. So hopefully this is pretty much a review, that you know how to plot these kind of points on the coordinate axes. And of course 0, 0 is always the origin. Now, as you go through Math 12, 13, and 14, you're going to find a whole bunch of different ways of plotting relationships, functions, equations, and things of that sort. So we'll start out with the most basic way. Number one is you make a table of the values. And so let's say we have this equation y equals x minus 1. We just make this little table that shows several values of x, and then we actually compute the value of y. So if we subtract 1 from each value of x, we get those. And then we treat those as coordinate points. And you don't have to write them as coordinate points. You can certainly read them off easy enough here, saying x equals 2, y equals 1. And then you make a plot of those points. And since this is a continuous equation, meaning you can take fractions if you want, you can take 1.5 and stick it in x and all that kind of stuff, we draw a line through it where our points are. Now we'll find when we have a line like this, we really only need 2 points. And so if you want to choose -3 as one x and 3 as the other x, with these 2 outside points, that would have been sufficient to draw the line. So we'll go through a number of ways to plot lines, but this is probably the most rudimentary way. And in fact, it doesn't even need to be a line for you to plot it like this. The thing about this method, though, is that it doesn't always tell you the whole story. For example, if you're plotting numbers and you put a few of them through and you see there's a trend, you might be mistaken where it turns around, goes the other direction, and things like that. So this is, unless you have a lot of points that cover the whole area that you're interested in, sometimes this method is not the most complete. Okay, so let's look at the distance formula here. We're going to have 2 points, and we want to find the distance between the 2 of them. All right, with a line, all we did was we took the difference, right? If we're looking at what's the distance between 2 and 6, we subtract 2 from 6, and we get -4, and take the absolute value, you get 4. So how do we do it on a diagonal? Well, what we make use of is a triangle where we have the horizontal distance and the vertical distance, And then we use the Pythagorean theorem. And if you remember what the Pythagorean theorem is, for a right angle, c squared equals a squared plus b squared. And so we can do the computation like this, and we find that that distance is going to be 5. Okay, so the y difference is the 4 minus 1, and then the x difference is the 6 minus 2. And so we really have an equation that looks like this, and it's way more complicated, or it looks way more complicated than it really is. I'm looking at the differences in the y's, which was 4 minus 3, and I'm looking at the differences in the x's, which was 6 minus 2, and then I'm going to stick them in my Pythagorean equation here, take the square root so I can get to c, not c squared. And so this formula is one of those that looks worse than it really is. The subscripts y1 and y2 just mean that you have two different points, x1, y1, x2, y2, and it really doesn't matter which one you choose first. You notice when you square something, you're making it positive. So if I, instead of did 4 minus 1 squared, I'll get 9. I can take 1 minus 4 and I get negative 3 squared and I still get 9. So the order of which point is y1, or which point is point 1 and which one is point 2 is completely arbitrary. You just pick two points. Just make sure that you take the difference between the y's and take the difference between the x's. Where you get into trouble is where you take the difference between y and x and then square that, which doesn't give you anything meaningful. Yes?
So see where you circled and drew arrows? I'm confused on how you got the numbers to put into the...
Okay, maybe I did it entirely backwards, so let me reconstruct it on the board here. So if I have 2 and 1, and then 6 and 4. Okay, so the vertical elevation is going to be the difference between the 1 and the 4. So I take my y's here, and I get 4 minus 1. And that's that distance there. And so I circled that. Now the distance, the horizontal difference, is going to be the 6 minus 2. All right, so maybe I should have used different colors, but anyway, in my triangle that looks like this, this corresponds to the difference in the x's, okay? And then this corresponds to the difference in the y's, or how much does it rise. Does that help? Or is that just more spaghetti on the board?
I get the first part, the vertical. You're just trying to find A, B, and C, right?
Exactly. And so A, if you think of that as the height, it's the difference between the two y values. B is the difference between the two x values.
And then is C just alone?
Yeah, the C is what you're finding. That's the, I put D equals 5 as the distance because that was the original question. So I put D as the distance in the formula, but D and C are the same thing in terms of the Pythagorean equation. Okay. Anyway. All right, we'll go on. I promise. The jokes I say in the future may not be any better, but they'll be shorter, okay? All right, so you have to memorize this, all right, the distance formula. It's just something you should know. It's something that's in calculus, you're going to use it a lot. Okay, so now let's look at the midpoint. What's the middle point between 2 points on a graph? And so let's look at the same 2 points, or actually this is 2 different points. What is the point that's halfway in between it? Okay, so if you take anything that's rectangular, like a book or something, or let me take this notebook, and I look at it, and I draw a line here, and I measure it, and I put a point there and a half. If I look at it this way, and I look along just this axis, I'll notice that the point is halfway in between the two ends. And if I look at it this way, I'll know that that point is halfway in between these two as well. So halfway in between two values is really easy. It's just the average, right? So the way you can calculate the midpoint is just by taking the halfway distance between the x values and the halfway in the y, and so that's just the average. You add the two values and you divide them by 2. So in this particular case, I got x equals 2, y equals 1. The other point is x equals 4, y equals 5, and so the average of the x values is going to be 4 plus 2 divided by 2, which is 3. And then the difference halfway here is 5 plus 1 divided by 2 is 6 divided by 2 is 3. So this point here, this point at 3, 3, is my halfway point. And so you write your midpoint as a coordinate pair, and if we want to write it as a formula, here again, this looks a whole lot worse than it really is. We just take the average. So what's halfway in between two numbers? You add them together, divide by 2. And so we do that with coordinates as well. We take halfway between the x's, halfway between the y's. And then we express that as a coordinate pair. So this is another thing to memorize. Okay? I'll let you copy that over. But conceptually, this is one of those things that you should be able to reason out. It's not really a formula that you have to memorize every nuance to it. Just remember that we're looking for a midway point, so it's going to be a coordinate pair, and then you look for a the halfway point in between both. Okay, so just with this little introduction, we talked about the coordinate system.
Wait, is that plus 3? Or, sorry, to interrupt you.
Yeah.
For the halfway points, x.
Yeah, they're all positive numbers here. There's no differences. We're looking at averages, so the average of 2 and 4 is 3. The average of 5 and 1 is 3. So we went over the coordinate system, the most basic way of graphing, distance formula, and the midpoint formula. So on Monday, what we're going to do is get into describing lines with equations. So we'll be talking about slopes and intercepts and things of that sort. So, so by the end of next week, you'll be able to characterize a line that goes through 2 points, or if you're given a line, how do you plot those 2 points? How do you plot that line efficiently? Where do lines intersect? What are the formulas for perpendicular lines to certain points and things of that sort? So we'll be going through all that. Okay, so have a nice weekend.
Thank you.